Okay, here we go. Hey, we're on. We are on. Okay, now this is a chart. Let me explain the chart to you, okay? So that when you look at it at home, you may not remember. I remember in algebra, when I took Algebra 2, I could follow in class, excellent, easy, A+. But when I got home, I just couldn't remember what she did, in class. These are the particles. I just chose gases because you can do volumes with gases. A solid obviously doesn't have a volume relative to molar volume of all the gases are the same, 22.4 liters, yes? So I chose all gases. These are the particles. This is the molar volume of each. I want to know, this is the representative particles. In other words, this is 6.02 times 10 to the 23, 10 to the 24. Remember, a mole is 10 to the 23. So how many moles is that? What would the volume be, and what would the mass be? Easy. And then for nitrogen, I chose 2 moles. For ammonia, I chose 84 liters. For carbon dioxide, I chose 1,000 grams. And for methane, I chose 2 particles of methane, just 2. Not 6.02 times 10 to the 23rd, but just 2 particles of methane, okay? So this first column is independent of the rest. These are the molar volumes, the molar masses, sorry, which is grams per mole. These are the molar masses. What is the mass of 1 mole of a particle? Yes? And then this is going to be, these columns will be dependent on 1. So if I know there's 2 particles of methane here, I should be able to do these 3 columns and etc. Clear? Okay, so let's do it. Let's do the molar masses. That should be very straightforward. So can I just do that quickly, or would you like help with that? Okay? Sabine, what's the molar mass of hydrogen?
2.
2, very good. Now remember, I have grams per mole up here, so I don't have to put in the unit labels right next to it. Clear? Yes? So this is going to be 2. Nitrogen is 28. Ammonia is 17. 44 and 16. Excellent. All right? So let's do this right away. If there's 6.02 times 10 to the 23rd particles, how many moles is that? How would you get that? How would you get that? Can I use like this square as scrap paper for just a moment? Is that okay? Is that okay? Set up a proportional relationship. Don't use dimensional analysis. Just set up a proportional relationship. Because I'm going to tell you why. And chemistry teachers and some chemistry students fight this, but I'm going to tell you why. If you do dimensional analysis, it really doesn't show you the chemistry. But a proportional relationship shows you more of the chemistry. Yes? It works on simply the conversion factor, but it's a proportional relationship. And that's 7th grade math. So I know that 1 mole is 6.02 times 10 to the 23rd, right? Well, I want to know how many moles 6.02 times 10 to the 24th is. So it's going to be 1 times 6.02 times 10 to the 24th, right? Divided by 6.02 times 10 to the 23rd. What is that value? What is, on your calculators right now, can you do that? Can you do that? Can you calculate on your calculators? Remember, I did some demonstration up here, videos on how to use a scientific calculator, a graphing calculator, and calculate that. So how would you do that? What numbers would you press? What numbers would you press? I'll use this as a scrap paper here. So it's going to be this times this divided by this, right? Yes? Well, we know that 1 times 6.02 times 10 to the 24th is going to be 6.02 times 10 to the 24, right? We know that, right? Yes or no? So isn't it going to be this divided by that? That might be a little bit Crazy? Do you see EE on your calculator? You know how to do this? So 6.02 second. Let me see your calculator. Is it on your calculator? May I use your calculator for a second? Yeah, yours is. You have it. EE. Okay. In this calculator, it's above the, is that a comma?
Yeah, it's comma.
Or a
It's comma.
comma, okay. And then you hit 2, 4, divided by 6.02 second, EE 23, right?
Which is 10.
Equals, and what do you get?
10.
You get 10. Do you see that? And that should make sense, right? Shouldn't that make sense? Oh, sorry. I'm handing her the marker instead of the calculator, okay? That should make sense. Why? Because it's going to look like this. It's going to look like this. Excuse me while I get rid of my chart here. You should be able to, at your age and your mathematical abilities, you should be able to look at it like this. 6.02 times 10 to the 24 divided by 6.02 times 10 to the 23. You should be able to look at it like this. You should be able to take it apart. Remember, they're factors. You can do that. Terms you can't, but factors you can. 6.02 divided by 6.02 is what? Is 1, right? 10 to the 24th divided by 10 to the 23rd is what? 10. What's 1 times 10?
10.
10. You see? Because this is going to be 1 times 10 to the 1. 1 times 10 to the 1 is simply 10, right? Because 10 to the 24th divided by 10 to the 23rd. You see that? Yes or no? Yes? In other words, a to the n divided by a to the m equals a to the n minus m. So 24 minus 23. What's going on here? Something weird? Okay, it's okay. All right. So may I erase all this? You get it? All right, let me put my chart back. Okay, let me put my chart back. Is that it? Is that back? Okay. So we got, how many moles did we get?
10.
We got 10 moles. So that's here, right? Now it's fairly straightforward. What volume would you get? What volume would you get?
220.
224, right?
Yeah.
Because 22.4 liters is 1 mole times 10 would be 224. And then what would the mass be?
20.
Yeah, you'd divide the number of moles times the molar mass, right? Would be what?
20.
20. Yes? I have 2 moles here. What would this be?
1.2 times 10 to the 24.
1.2 times 10 to the 24th, or simply 12.04. But I understand 1.2, that's fine. This is actually well done, Armindo. Very well done. Does everybody understand where you got that? Sabine, what is 2 moles, right? So what is 6.02 times 10 to the 23rd times 2? Isn't it 2 times 6.02? Right? What's 2 times 6? 12, right? So isn't that 12? Isn't 12 1.2 times 10 to the 1, isn't it? Isn't it 1.2 times 10 to the 1? Okay. Times 10 to the 23rd is 10 to the 24th. You got to know, if you don't know scientific notation, please come after school and let's learn it, because you can't do this without it. Yes? You understand? We're going to be using very large and very small numbers from now on till the end of the year. Okay. So what do we got? What's the volume now?
44.8.
So 2 times 44.8. Right? You say 44.2? Who said that? That's okay if you said 44.2. Did you say 44.8?
Yes.
Okay. So then, what would the mass be?
56.
56. All right. 84 is the volume. 84 liters. How many moles is that? Excuse me. How many moles is that?
3.75.
What is it?
3.75.
3.75. Is that correct? Okay. 3.75. So what's 3.75 moles, right? Now,
Sir,
it's going to, yes.
can you tell us how you found it?
Excuse me?
Can you tell us how you found it?
How I found it? I didn't find it. Somebody else found it and told me about it. Who found it? Armindo, explain to Baslin how you found it. In other words, explain to Baslin how you had 84 liters of this gas and you determined that it was 3.75 moles. Baslin, are you ready for the explanation? Armindo, go for it. I will narrate. I will be the play-by-play narrator. This is Armindo giving an explanation to Baslin. Go ahead, big guy.
What I did was, since I had 84 liters.
He had 84 liters.
Multiplied by the molar volume, which is 22.
You mean divide by?
Divide, yes.
Yes, he's dividing by. In other words, listen to this carefully, Basil. Are you ready? Instead of saying moles, I'm going to say, doesn't 22.4 liters represent a mole? Doesn't it? Yes or no? I'm asking you a question.
Yeah.
Can't I say that that equals 1 mole?
Yes.
So in other words, we don't say it's equal, do we, Laura? We say it's equivalent. It's just a way of pretending it's not equal, but it's really close, right? We just come up with a word equivalent. But you understand that, right? I'm saying that 22.4 represents a mole, right? Yes? Liters, right? So, Basil, look at it this way. How many 22.4s are there in 84? Right? You just got it, didn't you?
Yeah.
I just saw the light go on. Yes? Yes? People think it's a halo, but it's actually ding. So how many 22.4s are in 84? Well, there's 3.75, right? Yes? So how many representative particles would that be? Let's see. How would I get that? One representative particle is 6.02 times 10 to the 23rd, right? Yes? What would 3.75 moles be?
2.25 times 10 to the 24.
What did you say?
2.25
2.25
times 10 to the 24.
times 10 to the 24. Is that right? Is that right? So in other words, 6.02, I'm suggesting that 6.02 times almost 4 is going to be almost 24, right? 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 6 times, right? And that's about right. So it's 22.5, right? So she changes it from 22. He or she changes it from 22.5 to 2.25 times 10 to the 1 times 10 to the 23rd. Add the exponents. Yes? Do you follow me what I mean by that? In other words, a to the m times a to the n equals a to the m plus n. Correct? Yes or no? Yes or no? Okay. Okay, now. So, what's the mass of that then? 17 grams in 1 mole, 3.75 moles. What's the mass, guys? Come on, tell me.
63.7.
Excuse me, Sabine, you got your calculator out, girl? I want you working on this.
0.75.
You have Laura as a tutor. Okay? Laura will tell you everything she knows. Okay? So what's the answer? What do we got? 17 times 3.75 is what?
63.75.
What is it?
63.75.
63?
Yes.
Yeah, that's right. 63. Point what?
75.
Okay. What about this? 1,000 grams. How many moles does that represent? Remember, what's the first thing you shoot for? Everything has to be converted to what? Moles, yeah. You always got to convert everything to moles. Unless it's already in moles, right? Everything's got to go through moles. You cannot do it without moles. T, if I have 1,000 grams, right, of carbon dioxide, and there's 44 grams in 1 mole, how many moles does 1,000 grams of carbon dioxide represent? I want T to answer the question.
22.73.
Can we say? I hear something ringing.
It's a car outside.
Is the car outside? Okay. So what did you get? What is 1,000 divided by 44? 22 point what?
73.
22. Can we just say 23? I hate this 0.75 business. Is that all right? All right. So 23 moles. Is that okay? We're rounding there. We're going to get a lot of round off air, but who cares? Right? You get the point? Yeah? Okay. So what is 23 times what? To get this.
6.02.
So do it. 6.02 times 10 to the 23rd times 23. Sabine, you with us? You need a real calculator. You need a big girl calculator.
Yeah, I have one.
You have one. Where is it? It's home. Is it safe?
Yes, yeah.
Okay, all right, excellent. As long as it's safe, that's what counts. Yes?
Divide the mass by the molar.
Because you got to think like you're a chemistry student, okay? So doesn't 44 grams represent a mole of carbon dioxide, of that particle, doesn't it? It represents a mole, right? What's the mass of 1 mole? So if I have 1,000 grams, how many 44s go into 1,000? You get it? Once I say that, everybody understands it. It's amazing, really, how the mind works. Right? Isn't it? It's amazing. But yeah, that's all there is to it. It's nothing more than that. This is not hard. This is simply getting used to a bunch of rules. If you can read the rules of Monopoly and win, you can do chemistry. So all it is rules. That's all it is, nothing else. So how many is 23? Okay, so what is 6.02 times 10 to the 23rd times 23? What do you got? 6 times 25 is like 150, so 1.5, 1.35 times 10 to the 25 maybe. What is it? What do you got? Did I do it right? Isn't that scary, huh?
1.3.
Yeah, you got to learn to estimate, guys. What is it? 1.3,
By 10 to the
1.38. Is that what you said?
Yeah.
What did I say? 1.35? Little scary, little scary. Times 10 to the 25.
Yeah.
You see how I did that? I approximated it, right? So like 6 times 23, right? 6 times 25 is 150. Bring it down a little bit. Yes, you get it? Okay. So, what's this going to be? What is it? Like 20 times 20 is like 400. So it's going to be like 400 something. What is it?
550.
So it's going to be around 500. So what's 23 times 22.5? What is it? 23 times 22.5 is what?
515.
550 or 515? 515. Now this one is a little bit tough. All right? This is a little bit tough. I only got 2 particles there. Right? What's going to be the number of moles? What we need to do is, I'm going to bring this down, and I'm going to look at this. Can you see that? Can you see that?
Yeah.
Okay. So that horn is really starting to annoy me. I can hear that for whatever reason. Do you hear that horn?
Yeah.
Do you hear it loudly?
So,
I can hear it just in the background, but it's enough to put me off. Okay, so if I say to you, 1 mole is 6.02 times 10 to the 23rd, right? Yes? Okay, I want to know how many moles 2 particles is. Right? So it's going to be 1 times 2 is 2. So what is 2 divided by, put this in your calculators, do what I say. You ready? You ready? Can I do it over here? Can you see this on the board? Can you see this there? Yes?
3.1 by
So 2, because 1 times 2 is 2, 2, right, times 6.02, second, EE, 2, 3, equals. What do you got?
1.2 by 10 to the 2.
What did I say? I say, wait a second, I made a mistake.
Yeah, we're supposed to divide.
2 divided by, sorry,
7.24.
sorry, mistake, sorry, sorry. Cross multiply and divide, my mistake. My bad, right? My bad.
3.32.
What is it? I need the whole thing. It's gonna be a negative, right? So what do you got?
By 10 to the
All right, I need one person to tell me. Basilin with the new haircut. You look like a Republican. Excellent. What do you got?
3.32.
What is it?
3.32 by 10 to the negative 24.
Is that right? Did everybody? Do we have any verifications on that? Salama, what'd you get? Is that you got the same thing? Z-Man?
Yeah.
You sure? Did Z-Man get it, Salama, or is Z-Man lying? Z-Man, I'm telling you. You got a haircut too, I'm telling you.
Yeah.
You know, a prince of the desert gets a haircut. That sounds like a short story. You know what I mean?
Yeah.
I like that. Arabian Nights, one of the tales. And we you know what we're gonna call it? We're gonna call it Z-Man Gets Buzzed, okay? Excellent. A prince of the desert gets a haircut, in parentheses, Z-Man gets buzzed. I like it. You look good, Z-Man. I like it. Excellent. What else? What do we got? Anybody else? You got it? Can we put that in? All right. All right. So we're going to put that in here. And it's going to be, what was it? 3 point... Basil, what'd you say?
3.32 by 10.
That's how many moles. So small, right? Just 2 particles, right? So what about volume? So what is going to be, listen carefully. You ready? You ready? You ready? You ready? You ready? Professor? Yes? What is, if it's this many moles, and I know that 1 mole is 22.4, so what am I doing? I'm multiplying the number of moles times 22.4 to get the volume, aren't I? So what is 3.32 times 10 to the negative 4 times 22.4?
7.4.
7.4 times 10 to the what?
Negative 23.
Negative 23? Yes. Because it's going to be 3.32 times 22 is going to be like 73, right? Right? So that's going to be 7 point whatever times 10 to the 1 times 10 to the negative 24 would be negative 23. You get that, Laura? You with me? So what do we got? What is it?
7.4.
7 point,
4.3.
just say 4. 7.4 is good. Times 10 to the what?
Negative 23.
Is that right? Just because you see what happened? You see what happened? I'm going to put this up a little bit. You see what happened? In other words, 3.32 times 22.4 is 74 plus, right? Right? Which becomes 7.4 times 10 to the 1. Right? times 10 to the negative 24 becomes negative 23. Do you see that? You get it? You with me? Yes? Okay. And then the last thing is the mass. So if I've 16 is the molar mass for methane, what's the mass of just 2 molecules of methane, just 2 particles? What's the mass in grams? Again, we got to go back to the mole, right? So that's the number of moles. So what is 3.32 times 10 to the negative 24 times 16? It'll be 48 plus a third of that. 58? No. 58, 56, 55. What is it?
5.3
What is it, 5.3? 5.3, okay. So 53, right? So it'll be 5.3. Let me make that 5 a little bit better looking. Kind of a boring looking. 5.3 times 10 to the 23rd. No,
Yeah, negative 3.
negative 23, right? Right? Grams. All right, now if you can do that chart, you're going to be in good shape. Okay, can I cut? Yeah, finished? Okay. So that chart is, that's going to be a good chart. Let me just leave that up for a few minutes. Let you meditate on that. So make sure that you look at, your homework is due on the first, no, the 3rd. My daughter's birthday. The 3rd. Right? Right? Okay. All right. Okay, so, yes? Amy, how you doing back there? You all right?
No, you're joking.
Excellent.